Welcome back to gas laws. In the last video, we saw an introduction to gas laws, and then we talked about the Boyle's law, which is also called the Mariotti law. So Boyle's law is Mariotti's law. And then in this class, we'll be talking about Charles' law, the second of such common gas laws. Now, Charles' law was put forward by Charles, but published by Gay-Lussac. And Gay-Lussac, of course, published it in the name of Charles. Charles' law looks at the relationship between volume and temperature. That is in the case where the other two parameters are kept constant. Believing you remember the other two parameters that are used to describe gas behavior, which are amount of gas, N, and pressure of gas, P. So in the presence of N and P being constant, we have V and T related like this. And if you're used to proportionality constants, you'd realize that what this statement is telling us is that the volume of a given amount of gas is directly proportional to its temperature, which in effect means that as the temperature of the gas rises, the gas expands, so its volume also increases. And on the other hand, as the volume drops, the temperature will also drop. Now, in a case where we were to introduce a constant into an expression like this, the typical thing you see is V becomes equal to KT. So if V is equal to KT, it means that if we make K subject of formula, we have K equals V over T. So with K as the subject, this is what we have, V over T. Now, because V over T is constant, it means that V1 over T1 will be equal to V2 over T2 would be equal to V3 over T3, because the law says here that V over T is constant. So when we have questions on Charles' law, we usually solve with that formula. So V1 will be initial volume, this is initial temperature, that's final volume, final temperature. But remember that the temperatures here are absolute, meaning measured in Kelvin. Now, to apply that, here's a question, a sample question for us. It says 400 cm³ of an ideal gas was heated from 27 degrees Celsius to 327 degrees Celsius. What will be its new volume, this time in liters? Now, a fair understanding of this question tells us that as of when the temperature was 27 degrees Celsius, the volume of gas present was 400. Now, what happened to the gas afterward? It was heated, and the temperature went up from 27 degrees Celsius up to 327 degrees Celsius. Now, we are required to calculate the new volume at this new temperature. So I'm simply going to say that this is my V1, and this new volume would be V2. So that for the temperatures, 27 degrees will be my T1, while 327 will be my T2. But of course, T1 and T2 cannot be used in their original forms now, because we said before that temperature must be converted to Kelvin. In chemistry, we use absolute values of temperature for solving. So how do we convert those values to Kelvin? In our previous lesson, we said that degrees centigrade or degrees Celsius temperatures can be converted to Kelvin temperatures by adding 273 to the values. So it means that my T1 becomes 27 plus 273, which is 300. 27 and 273 will give me 300. And then T2 would be 327 plus 273, which gives me 600. So now that I have absolute values for T1 and T2, looking for V2 means making V2 the subject of this formula. So I'm going to write V2 equals V1 T2 over T1. So this becomes V1 400 times T2 600 over T1 300. V2 here becomes 300, 2 there, 400 times 2 gives me 800. So 800 cm cubed is the new volume. But wait, it says new volume in liters. Now you'd remember that cm cubed is the same as milliliters, just as liters is the same as dm cubed. So how do I convert this value to liters? Of course, I'll divide by 1000. So I'll say here V2 in liters equals 800 over 1000, and that gives me 0.8 liters. So that's the simple solution to our question. Now, the most difficult part of questions on Charles' law is here. Your ability to remember to convert your temperatures from Celsius to what? To Kelvin. Once you're able to do that, you will not have any issues, hopefully. Now, another thing is this. Looking at our T1 and T2, you'll see that T2 is twice the T1. That's like double of the T1. And from this line, we said if volume rises, temperature will rise. If volume falls, temperature will fall. They usually vary in the same way. That's direct proportionality now. So looking at T1 and T2, what do you think happened to temperature from T1 to T2? Yeah, it became double, right? So since the temperature doubled, what do we expect of the volume? It should also double. Did it double? Yes. 400 became 800. So it's simple. Very simple. Once you see questions on Charles' law, remember that volume and temperature will vary in the same way. And that's usually in terms of multiples. Please don't check in terms of sums, like addition. Don't say 300 to 600. Oh, the difference is 300. So here, 400 plus 300, 700. We don't use the plus factor, we multiply. So this multiplied by 2 is that. So this multiplied by 2 will also be that. That's how it works. So in the next video, I'll show you an example on our next law, which is Avogadro's law.